luckiest guy. So
you're out of dead or and a fireman.
Someone chill, dog.
All right. He kept some candy. Now he's all hyped up. All right. So guys.
Wait, let me finish.
So now division again. Division's not that much tougher. It's just you have to flip it and multiply. So again, similar to the one we just done before, where the first the first fraction is going to stay as it is, but we flip the second one and multiply. Again, cross canceling here as we go. Oh, there's lots of canceling here with numbers. Because then the 4 over 2 can cancel too, right? I hate the double cancel. I don't know how to show it. So 2 and 1.
Ace.
That's good.
I thought you couldn't do that. No, you can't.
Up and down you can. Breaking rules here. All right, how about the x's?
2 on top.
2 on top. And the y's?
1 on top.
1 on top. So technically this wouldn't need to be a fraction at all anymore. You could just write it this way as well. Over 1 is fine. All right, so we're talking about dividing here again. So right away, I would suggest trying to flip that fraction and factoring. So there's a bunch of factoring we can do in these problems. So I'll give you guys a minute to start them. I'll help you guys in a second here, but don't forget to switch that second fraction. Did you guys factor right away, or did you flip first?
I flip first.
Can you cancel ones that are on top of each other?
Like if one's on top or
Straight up and down, yes.
Yeah.
Yeah. So we're flipping these fractions. So we flipped it. If you're able to do a few steps in one, I'm fine with that, as long as you kind of can follow what's going on. But so we switched it. Again, we have a bunch of different factoring we can do here. This is another one that kind of has all the different types of factoring built in here.
We need a harder one. This is too easy.
Oh my gosh. A lot of x plus 4s here. Right? So this one, just be careful that you're not canceling too much. So making sure that I can't just cancel, x plus 4, like there's 3 on the bottom, so I can't, like just making sure that you're canceling the right amount of values. So like here and here, so straight up and down you can cancel. And then like here and here if you want it doesn't matter as long as you realize there's still going to be one x plus 4 left on the bottom. Now x plus 4 and x minus 4 seem like they want to cancel somehow, but they just don't. They're not the same. Think about it as if you knew what x was. If you knew x was 6, minus 4 is not the same as 6 plus 4. They're not the same value.
Oh, we forgot to find the domain.
Yeah, oh yeah, so I would probably find the domain here on this step so you can kind of go, since we can still see it, we can do that in a second. So our final version is this. Again, you do not need to distribute. You can distribute if you wanted to. We don't need to. Careful, the 4 and 2 do not cancel because of that subtraction, so just making sure. And so again, Becca mentioned the domain. Again, I like going to the step where everything's nice and factored for us. I think it's just negative 4 and 4, right? Oh no, just negative 4, right?
Yeah.
We don't even need positive 4. That was on top. Oops. All right. Now this next one, what's going on with that 12a plus 18? Where is that right now? Technically, it's over 1. Look at you, Garrett. Holy cow, the morning must be like, I know. But Garrett's become star student, just in case you guys are aware.
Third period was not good.
Honestly though, after lunch, I don't know that that's the best time for anyone for math class.
See,
Like,
I think I kind of like it after lunch.
Yeah, but
No, I'm also allergy.
English first period sucked.
I'm pretty sure that Sawyer was always falling asleep. I don't know. I think he would.
Unless they were like that.
All right.
Almost what?
So we flipped and multiplied. Now this one's a little bit different in terms of the factory.
Yeah, I do. I do.
I can take a 6 out of this one. So our canceling here. You notice what else can cancel?
The six
Simplify.
and
Yeah, the 6 and 3 can be simplified. So this becomes a 1 and a 2. So there's nothing left on top other than 1. The 1 does have to be there still. And we're left with a 2 over a plus 3 on the bottom. And again, we want to go back to that step where everything's nice and factored for us to talk about what our excluded values are. Well, you can distribute, you don't need to. So I said that before, so if you want to distribute, you can. So this is the same thing as this. But they're not considered more simplified, one or the other, so either way is fine with me. This one though, we have to solve this, we have to move the 3 over, so it's a negative 3 halves that a also cannot be. So watching out for that, the 6 doesn't, we don't have to worry about 6 at all. So those are our excluded values there.
Wait, where does the negative 3 halves come from?
Because if you put 2a plus 3 equals 0.
Yeah, if we want to,
You have to subtract.
Oh.
Right.
Okay. I'm sorry.
no, it's fine.
Yeah.
Never ask a question again.
Yeah, usually so.
Better be sorry. All right. And then we'll finish up with our last few with addition and subtraction. I will warn you guys, the addition and subtraction are a little bit funkier, but all right. So finding the common denominator is what's super difficult with adding and subtracting. The biggest thing is you see these two, they're so similar, and you might just say, well, if I could just subtract 3 from this one, they match. You can't do that. We have to multiply something to make it match. So in order to get a common denominator in this case, we just basically are going to multiply the other one by that one's denominator. So in this case, nothing can be done with these in terms of addition or subtraction. Now that won't be the case for these next couple, just so you guys know. So this one's kind of unique, that basically the new denominator is just going to be, it's going to essentially just be what the other one has. So that means this one needs to get m plus 1. So I'm going to have to distribute now. So like Cash talking about distributing before, that is important here. And this one's going to need an m minus 2. So I will distribute a little bit. I'll have 3m plus 3. And here, 4m minus 8, right? So in a problem like this, we just can multiply by what the other one has. Now we're going to combine like terms on top. So 3m and 4m is 7m. 3 plus a negative 8 is a negative 5. That can't be factored or anything good happens with that. So, and again, we don't need to FOIL the bottom because that won't do us any good anyway. So it's not necessary to distribute on the bottom. And I think you guys are getting the hang of the domain, but the domain would just be can't be 2 and negative 1, right? Now letter B is a little bit nicer. It doesn't look nicer to begin with, but do you see what we can do in letter B? Yeah, you can actually factor this, and it's going to look a lot like this one. So this one's actually a little bit easier problem, even though it looks tougher. So we're going to rewrite this fraction, oops, as 3x plus 2. I'm going to take a 3 out of that. So, since this is 3 times x plus 2, what does this one need? A 3. So I can just multiply this one by 3, and they already match. But if I do that to the bottom, I have to do to the top as well. So do you guys see now the bottoms are the same, but the top on this one's going to become a 9 because I had to multiply it by 3 because that's what it was missing. And again, we don't have to distribute, you can if you want. Yeah. Yeah, 14. I can add. Do all this complex math and then get the engine wrong.
If you took a 3 out of like that, like the 3x plus 6, wouldn't the 3 on top be 1 then?
You can't, oh, good question. You can't cross cancel with addition.
Oh, okay.
Yeah, I know that's I know sometimes we get so used to like, but think about it like if I had 3 over, I don't know, 7 plus 1 over 3, you wouldn't cross cancel with, you know. So once you look at it without variables, I think it makes more sense. So you can't, good question though. That, yes, that happens. You're not the first one who suggested trying to do that. So then again, x can't equal negative 2. All right, last one here, looks horrible, really not that bad, because there's a whole bunch of factoring we can do. Now, the subtraction does add a little bit level of difficulty to this that you might not notice until a little bit later, so we'll get into that. All right, so we're going to do some factoring here. But I like to leave a little bit of space for myself just in case I have to put something in there. So I did a bunch of factoring, and it already, in my opinion, looks better. What does the first fraction need that the second fraction has? What does this first fraction need?
thought I was playing.
Yeah, it doesn't have the x plus 2, so we're going to give it the x plus 2 to top and bottom. How about the second fraction? It just needs a 2. So that 2 does need to be there. As much as you kind of want to cancel it and do weird things with it, we have to make sure we include it here. So times 2 times 2. So I do like to distribute up here just so that we have kind of the right stuff here going on together. So 5x plus 10, and then this would be minus 40. I guess this is a great one to explain the subtraction. There's a little bit extra with subtraction that kind of comes up sometimes, not here though. Ooh, actually this one, we might simplify a little bit more unless I did something wrong.
Where'd you get it?
It's 40.
10 minus 40, right?
Oh, I thought the middle was like a subtraction.
No, yeah.
Oh, really?
Yeah, really.
Does anyone see what we can still do? This one actually I think simplifies a little bit more. Yeah. Yeah, and a lot of times they say it's okay to leave it. However, you should always kind of check and see, would factoring it help us? If I factor that 5x minus 30, kind of doing a little bit of forethought, kind of a little bit of chess play here, where we kind of think ahead of our next move, we can see that this is actually going to be helpful in this case. Because those x minus 6's can cancel then. And I will tell you that comes up a lot more often with subtraction, just because of the way problems work out and kind of interesting things happen there. All right, questions? Yeah. Yeah, thanks for waiting. So I have a worksheet for you guys. I'll get that to you.
What would be the domain of that?
Oh, yeah, sorry. Look at you.
Okay.
Yeah, so just 6 and negative 2. Yeah.
I
yeah.
don't know if there's any other weird.
No, no.